Just now that one.
Huh?
Just now that one.
Which one? This one?
Eh, no, just now you do the number 4 one and number 5.
4 and 5.
Just now you delete that one.
No, where is the question? This one? Is it this?
Not
Huh?
this one. Just now you delete that one.
Where the question come from? Here.
Not
Not this
this
one.
question.
Not this one. This one.
Just now you delete that one.
It has to come from here. Number 5. This one. This one. This one, number
Yes.
5. Okay. Number 5. The second term, T2. Yes, this is the one. This is the one. Okay. So we have T2 equals to 2 over 3. 2 over 3. 2 over 3. Then AR equals to 2 over 3. Okay. Okay, then fourth term is 1 over 54. T4 equals to 1 over 54. AR to the power of 3. AR to the power of 3 equals to 1 over 54. 1 over 54. So the technique that we use, we divide. You use this equation 2, you divide by this equation 1. This equation 1. So when you divide these two, so A and A will cancel. The R cube and the R, you will get R squared. Okay. So R squared equals to 1 over 54. 1 over 54 times by 3 over 2. Divide by 2 over 3 means times by 3 over 2. Times by 3 over 2. So how much is this? 54 divided by 3, 1, 24, 18. 18 times 2, 36. So it will be 36. So R square is 36. So R equals to square root of 36 is plus or minus 6. So there are two possible values of R. So one possible value, all the terms are positive. So all the terms are positive, we cannot have the negative R. So it will be a positive 6. So it's not square root 6. It's not square root 6, it's square root of 36, and this is it. So we have found the value of R. What is A? So 6R substitute back equals to 2 over 3. 2 over 3. Cancel 1 over 9. A equals to 1 over 9. A equals to 1 over 9. Again, cancel 3, 1 over 9, correct. So A equals to 1 over 9. 1 over 9. Okay, so this is the answer for the first term and common ratio. So they want to find the nth term, Tn. Tn equals to AR to the power of n minus 1. AR to the power n minus 1. Okay, so what will it be? Equals to 1 over 9. 1 over 9 A. Then the R is R is 6. R is 6. 6 to the power of n minus 1. So AR to the power of this 6 nth term to the power of n minus 1. N minus 1. So this is the Tn. Equals to this one. Actually, you can simplify some more. So it's actually 1 over 9. It's actually 1 over 9. 1 over 9. 6 to the power of n. 6 to the power of n. Now the 6 to the power of negative 1 is actually 1 over 6. 6 to the power of negative 1 is actually 1 over 6. Okay, so it will be like this. It will be 6 times 9 is 1 over 54. So it's 6 to the power n. 6 to the power n. 6 to the power of n divided by 54. 6 times 9 is 54. Okay, so this is the answer. Right. Let me see. This is it. Then okay. That's all. We carry on with today. Today is okay. Where are we? Did I show you this question number 6? Question number 6 the other day? Yes or no?
Yes.
Yes, I've shown you. Number 8. Number 8,
No.
not yet.
No.
Okay. Number 8, not yet. Then I go through number 8 with you. Okay. You read question number 8. Find the smallest.
Find the smallest term of the geometric progression 27, 18, 12 that is less than 2.
Less than 2. Okay. So first of all, you write down what is given there. A is 27, right? So A is 27. Then what is the R here? 18 divided by 27. 18 divided by 27 is 2 over 3. So by looking at the geometric progression or the geometric sequence, you can identify the value of A and R. You can identify the values of A and R. Now what you want to find is, they say if you carry on like this, 27, 18, 12, and so on. If you carry on like this, it will come a time when the value of Tn is less than 2. I don't know when is it, but it will, because I know that the number is getting smaller and smaller. So it will come a time when the value of Tn is less than 2. So I have to find that value of n. So I create this inequality. I say Tn is less than 2, right? Tn is less than 2, it means that AR to the power n minus 1 must be less than 2. Okay, so far this one okay or not? The first statement, this one. Is this okay? Okay. Now, this is just substituting the formula into the inequality. So the next step will be replace the A with 27, because I know A is 27. Then replace the R with 2/3, because I know the R is 2/3. Then this is the inequality. So now we have to simplify this inequality. You cannot do anything to this 2 over 3. You know why? Because the whole thing is enclosed inside this n minus 1 there. You cannot do anything. So just leave it as 2 over 3 n minus 1. But the 27 you can bring over. So you bring over 27 is 2 over 27. Now, do you notice that do you notice that the index is an unknown? The index is n, we don't know. So earlier on, I told you if the index is unknown, the power is something involving n. You have to take log. Why? Because once you take log on both sides of the equation, left-hand side you take log, right-hand side you take log, then you get this. Now, the reason why you want to take log is you bring this n minus 1 to the front. According to the law of logarithm, you can bring the n minus 1 to the front. So when you bring the n minus 1 to the front, you still leave it in the bracket form. You still leave it in the bracket form and don't open up the bracket. Okay. So this step, okay or not so far? Okay, right. Then you notice that this log 203 is actually a number. You calculate from the calculator and tell me what number is this? Log 203. Use your calculator. Calculate. How much is it?
Negative 0.7.
Okay, negative 0.7. It is a negative number. Then this one? Log 2 over 27.
Negative 1.130.
Okay, right. So it's also negative number, right? It is also a negative number, right? So next one. Okay, so this log 203 is a negative number, right? So I bring this, okay, wait, so this log 203 is a negative number. So when you bring this log 203 over, this negative number, log 203, you bring over, the inequality sign need to change. Okay, the inequality sign here. This inequality sign here at first is less than. But when you bring over this negative number over to the other side, you have to change it to greater than. Or do you know this? When you divide by a negative number, the inequality will change. Okay, so you know, then, okay. Now you can use the calculator to divide this with this number. So when you divide the two numbers, when you divide this number by this number, right? So it is 6.4. Now, a number bigger than 6.4, what number should that be if it is bigger than 6.4? Bigger than 6.4. Huh? Is it 6? 7, correct. Bigger must be 7. Even if it's 6.1, you say bigger than 6.1, it has to be 7, cannot be 6. No matter how near it is. Oi, apa ini? Show. Oh, one cannot. Show, okay. Show, okay. Yeah. So now, the next highest number, and it must be a whole number. So it has to be 7. So once you replace with 7, it is no longer an inequality. It is an equal sign already, right? Bigger than 6, I mean, is equal to 7. Bring the 1 over, so we know the answer, n is 8. Okay, so far can follow or not? Any question? Can. No question. Okay, so the technique is to use log. Okay, the technique is to use log. Right, next one. Next page. Okay, now we go on to the sum of first n terms. Now, how to find the sum of first n terms? Sum of first n term, let us understand what is the meaning of sum of first n term. Sum of first n term means T1 plus T2 plus T3 until you get Tn, until you get Tn, right? Until you get Tn. Okay, so I think something wrong with my clicking. Okay, so next one. Now I replace the Tn with A T2 with AR, T3 with AR square, AR to the power of 3 until Tn is AR to the power of n minus 1. Okay, but this Sn is like this. I cannot shorten it. I cannot make it into a very short term. So the trick is to multiply this equation 1, this Sn, with R, multiply with R. So when you multiply Sn with R is Rsn. You multiply A with R is AR. You multiply AR with R is AR square. So each of the term above here has increased by 1 R and it becomes like this. Okay or not? The equation 2. The equation 2 comes from equation 1 by multiplying with R. So every term there also increased by R. Now, in this way, I found out that there are many terms in common between equation 1 and equation 2. Let us look at this AR. Is there an AR at the top? This is AR
No.
square. Is there AR square at the top? Yes. This
Yes.
AR cube. Is there AR cube at the top there? Equation 1? Yes. So
Yes.
many of these terms, they are all the same. They are all the same. You know, except two terms only. What are the two terms that is not the same? These two terms. This term A here, the bottom don't have. This term AR to the power of n, the top don't have. So the rest, all these are, they can cancel away. Cancel away. Cancel away. Cancel away. This AR cube can cancel with the AR cube there. AR to the power n minus 1, AR to the power n minus 1 can cancel away. So if I take equation 2 minus equation 1, equation 2 minus equation 1, the left-hand side is this one, Rsn minus Sn. So we have Rsn minus Sn. The right-hand side, I have this one and this one, the two circle term left, AR power n minus A. So far until here. Can follow or not?
Can.
Any question?
No.
No, can follow. So both sides, left side minus the left side, right side minus the right side. Left side minus left side, I have this. Right side minus right side, I have this. So this actually, both terms, they have Sn. I can factorize the Sn. So factorize become Sn R minus 1. Here, both terms, they have A. I can factorize out the A. So it's A R to the power n minus 1. Okay, so I move this R minus 1 to the right-hand side. So finally, I found out, oh, Sn is actually a very simple term like this. There are not many terms. It's just like this. It looks like this only. So Sn is equals to A R to the power of n minus 1 divided by R to the power of n. Okay, right. So this formula is true for the values of n greater than 1. This v then cut away. It means for all values of r bigger than 1. Now, then you may ask me, what if r equals to 1? If r equals to 1, that is not a geometric sequence. It's not a geometric sequence. So r cannot be equal to 1. Now, another thing is r cannot be equal to 0. Because if you put r equal to 0, there is nothing. Every term is 0, 0, 0. Right? So this r cannot have these two values, 1 and 0. Then you may ask me, hey, 1 and 0 cannot lah. Negative numbers, the r can or not? Can. If it is negative number, then the r will be like this. The formula for Sn will be like this, right? Terbalik, r to power n minus 1, it becomes 1 minus r to power n. R minus 1, it becomes 1 minus r. So it will be like this, right? It will be like this. So this sum of first n terms, there are two formula. One formula for the value of r bigger than 1, one formula for the value of r less than 1. So Sn has two formulas. So far, okay or not? Can
Okay.
follow? Can. Can, then we continue. Okay. So we look at the first example. The first example is question number 1 here. Find the sum of each of the following geometric progression. So the terms, they are 1, 2, 4. Then you find the sum until the 7th term. So I write down which formula. The first formula or the second formula? Right. Now
First formula.
to know whether it's the first or second formula, you write down here A is 1. You write down A is 1. Then what is the R? R is 2 over 1. 2 divided by 1 is 2. So the R is 2. This one is R greater than 1. This one is R less than 1. So R equals to 2 is for the first. Use the first or use the second one?
First one.
First one, correct. So we use the first formula, A bracket R to the power n minus 1 over R minus 1. So in this formula, you substitute in the A equal to 1, substitute in R equals to 2. R equals to 2. Then you simplify. 2 minus 1 is 1. So no need to write. 1 times this thing is the same. So what we have is actually only 2 to the power of 7 minus 1. 2 to the power of 7 is 1 to 8. 1 to 8 minus 1 is 1 to 7. Right. So next one is this. Next one is this. So you try this one. This one. So try. Right? You try this 1D. Right? Okay, then we go on to the next question, number 3. Okay, number 3. Now, how to solve different types of questions involving the sum of first n terms for a geometric progression. So we're going to see, right? This one is the same as number 2. I show you number 3. Okay, you read question number 3.
The sum of the first n term of a geometric progression is 15, 3 per 4 if the first term and the second term of the geometric progression are 8 and 4 respectively. Find the value of n.
Okay, so I write down sum of first n term is this 15 and 3 over 4. So I write down Sn is 15, 3 over 4, right? Then here they say the first term is 8. So I say A is 8. They say the second term is 4. So I write down T2 is 4. But what is T2? T2 is AR. So AR is 4. But A is 8. No, A is 8. So I put down A equals to 8. 8R is 4. R is 1 over 2. So with the value of A and R, I can solve anything. Anything they ask, I can solve. So where is it now? Here, right here. We write down Sn equals to this one, 15 and 3 over 4. Then you write out the formula A R power n minus 1, R minus 1. 15 over 4, I change to improper fraction. Improper fraction is 63 over 4. So rewrite the equation again, right? Because I cannot use this formula R to the power n minus 1, R minus 1. Because the value of R is half. Half is less than 1. So I cannot use this formula. I have to use the other one, the second formula. 1 minus R, 1 minus R. Okay. So I write down this formula, 1 minus r power n and 1 minus r. What is A? A is 8. R is 1 over 2. R is 1 over 2. 63 over 4. Now, you want to solve this equation, you have to move the numbers first. The numbers outside the bracket first. You don't open the bracket. Once you open the bracket, there are many terms that you cannot solve. So you don't open the bracket. Divide by 16 first. Divide by 16, it becomes 64. Now, 1 minus half the power n is a negative 4. So I have to move this over to the right-hand side so that it becomes a positive number. So move to this side, become positive number. Then 63 over 64, I move to the left-hand side. So 1 minus 63 over 64 is actually 1 over 64. And this one cannot do anything. This one, you can just leave it as 1 over 2 to the power n. Now, this one, if you don't know how to do, then you have to use log. You have to use log. But I can recognize this number, 64. 64 is 2 to the power of 6. I can recognize it. So now I know n is 6. But if you cannot recognize, what must you do? You have to take log like this. You have to take log on both sides. If the power is unknown, then you have to take log on both sides. Right? So this one, I know that I don't have to take log. So I know n is 6. Any question so far? Which step you cannot understand?
No.
No, can understand. So we go on to another type of question. Another type of question. The type of question is this one, number 5. You look at number 5 here. You read question number 5.
The fourth term of a geometric progression is 40, 55, 54, and the seventh term is 1458. Find the sum of all the terms from the fifth term to the ninth term.
Now here they say find the sum of all the terms from the 5th term to the 9th term. Did they say find the sum of first n term or not?
No.
No. So our formula for sum of first n term cannot be applied directly. You cannot apply directly, but you have to apply indirectly. Or that is one thing that makes it different from other questions. Number 1. Number 2, they give you 4th term and 7th term. Why is it that they give you the 4th term and the 7th term? What must you do with these two numbers?
The fourth term is the first term.
You have to form two equations. 4th term and 54, you form one equation. 7th term and 1458, you form another equation. With these two equations, you can solve for the values of A and R. Okay, with these two equations, you can solve for the values of A and R. Knowing the values of A and R, you can find the sum from the 5th term to the 9th term. How to do it? I'll show you how to do it. Okay. Okay, how to do it? Right. First one, we say the 4th term is 54. So T4 is 54. Now what is T4? A to the power of AR to the power of 4, is it? No. It is AR to the power of 3, 1 less. Okay. Next one. They say T7 is 1458. What must you do with this?
AR 6.
Yes, very good. AR to the power of 6 is 1458. Now, what should you do with these two equations, 1 and equation 2? You cannot subtract them like you do with our arithmetic sequence. Your arithmetic sequence is add and subtract, but this one is multiply or divide. So what you need to do is you take the equation 2 divided by equation 1. Don't subtract, no? If it is arithmetic progression, you subtract. If it's geometric progression, you divide. So when you divide A with A, no more A. A to R to the power 6 with R cubed. 6 at the top, 3 at the bottom. Cancel, 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 cancel. How much you have left?
3.
So R to the power 3. Okay. Then 1458 divided by 54. So you use your calculator, you divide, you get the answer is 27. So R cubed is 27, then the R is 3. If you don't know, then you take the cube root lah. Cube root of 27. Cube root of 27 is 27 to the power of 1 over 3, right? You use your calculator, 27 to the power of 1 over 3. You put the cap there, then you put 1 over 3, then you put the bracket, and then you get the cube root of 27. So answer is 3. Okay, then you substitute this answer, R equals to 3, back into equation 1. So 27A is 54, A is 2. So we have found the values of A and R. Now, the question wants us to find, if you look again, find the sum of all the terms from the 5th term to the 9th term. 5th term to the 9th term means they want T5 until T9, right? T5 until T9. How to get? If we look at T9 is 1 until 9, it's not 5 until 9, right? Not? So this S9 is not the answer. Then you look at the other one, S4. S4 is from T1 until T4. It's not T4 until T9. So what must we do? So we take the equation 3 minus equation 4. 3 minus 4, what happened is like this. What happened is like, okay, I think we stop here. We continue.